Hey there, first grade. How's everybody doing today? And welcome back to another remote learning math lesson with Mr. Enzi. Today, we are going to go back to our measuring skills. And today, we're going to practice measuring some paths, some crooked paths, not that straight line that we used to measure before. So let's get started as I shrink myself into the corner. Today, we are going to be doing grade 1, lesson 5.7, measuring a path. And if you have some paper clips nearby, you'll need your paper clips for measuring purposes. And then you'll need your whiteboard and marker. So you might want to hit that pause button while you gather up your supplies, because we are going to get started. Today, our math message. And of course, that's our warm-up. So let's take a look. Max measured his shoe. Here's Max's shoe. He says it is 9 cubes long. Do you agree? Explain. Well, there's Max's shoe. And there are his cubes that he used to measure. Now, Max says that his shoe is 9 cubes long. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, do you agree with Max? Is his shoe 9 cubes long? Hopefully you said no. And that's because Max left some gaps between the cubes. He left some spaces. And we can't leave spaces when we measure objects. So let's go and see how many cubes Max's shoe really is. Let's see. Oh, here we go. So we can now count our shoes here. Let's see here. All right, count our cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 cubes long is Max's shoe. And we didn't leave any gaps. We didn't overlap or anything like that. Now you might be saying there's a little gap here, but that's, my cube really fits perfect there. It's just hidden behind the picture. Okay? All right, awesome job. So it's important that when we measure length, length is how long an object is from end to end. And we've been measuring straight lines, and we've been using paper clips. We've been using pennies, and we've been using the cubes. But I wonder if we could also measure a curved line. Look at this. This is called a curve. It doesn't go straight. I wonder if an object like that could be measured. The answer is yes. We could measure a curve. I wonder if we could measure a crooked path, like this. 1 part, 2 parts, 3 parts. It's made up of 3 little lines. We can also measure a crooked path. And today we are going to learn how to do it. Now, some of our rules still apply, whether it's a curved line or a crooked path. But let's review some rules when measuring. Whenever we measure, we can't leave any gaps. No gaps. And of course, our gaps means that we have some spaces. We cannot overlap. Do not overlap. Overlap means when one sits on top of the other. We can't do that when we measure. We won't get an accurate measurement. Remember that we cannot use different sized objects to measure. Look here, we have all small paper clips, and then we decided to use a big paper clip. We can't use different sized objects when we measure. And you have to measure from end to end. And here you can see we didn't do that. We only measured the middle of the pencil. When we measure from end to end and we don't overlap and we don't leave gaps and we go in a nice straight line, notice that we have a complete measurement. But how can we measure something that is not straight? Something that is crooked, like the path I have here. Well, that's what we're going to learn today. I got my paper clips ready, and I still want to measure from the end to the other end. Now, it's important to know that this crooked path is made up of 3 little line segments. Here's one line segment. Here's another line segment. And here is a third part to my line. Look at that. So this crooked path is made up of 3 little parts to it. And we have to be able to measure every part. So I'm going to start. My first line part is 1 paper clip, 2 paper clips, and 3 paper clips long. So it's about 3 paper clips long, right? My 4th paper clip is too long. So it's about 3. So I'm going to write that number, 3. Now I have to measure my other part. So now I'm going to take my paper clips and I'm going to measure the other part. So I'm going to turn my paper clip to the right way. And then I have 1, 2, about 2, right? It doesn't have to be perfect. So now I'm going to write 2 where that line is. There it is. And now I have to measure my very last part. Let's see. 1, 2, 3. It's about 3. Now, if I took another one, notice that it's going to go way past it. So I'm going to say it's about 3. And I'm going to write that number down. 3. Now, I want to find in all. Well, there's a couple ways I can do this. I can count every paper clip. 1, 2, 3, 4, 5, 6, 7, 8. Or I can add up my numbers. So go ahead and get your whiteboard ready. Let's write a number model for this. 3 plus 2 plus 3 more equals, now we know our doubles fact, 3 plus 3. 3 plus 3 equals 6. And 2 more, 6, 7, 8. So our answer is about 8 paper clips long. And that's how we would measure a crooked path. Let's try another one. This time, our path doesn't have 3 parts to it. This time there's 4 parts. Here's one part. 1, 2, 3, 4 parts. So we have to measure each part separate so that we can get an accurate result. So I have my paper clip. I'm going to start my measurement with my first part. So far I have 1 paper clip, 2 paper clips, and there's number 3. So I'm going to say, about 3. Maybe I can say about 4. Let's see. Yeah, we could probably say it's about 4. About. And remember, about means it's close. It's not exactly 3. It's not exactly 4. But I'm going to call that 4. All right. So now I have to measure my second part. So I'm going to get my paper clip. I'm going to turn it around so that it's going the same way. And then I'm going to start to measure that part. So now I have 1, 2. That's about 2. I can't go more. So I'm going to write 2. So far, we have 1, 2, 3, 4, 5, 6 paper clips. So now I'm going to go ahead and measure the other part. And I go from end to end. All right, let's see. 1, 2, 3. And that pretty much takes me to the end. So I'm going to write 3. And I still have to measure my very last part. So let's go and get a paper clip here. So now we have 1. And I can probably get another one. Yeah, it's either about 1 or it's 2. I don't know. What do you think? It's kind of in the middle. So because we're saying about, I'm just going to go ahead and make it 2. Now, how many paper clips did we use in all? Well, we can count every paper clip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's write the number model on our whiteboard. 4 plus 2 plus 3 plus 2 equals, and we counted 11. Now, if I couldn't count 11, and I could probably do 2 plus 2 is 4. And then I have 4 plus 4 is 8. And 3 more, 9, 10, 11. So you can count all those paper clips, or you can use addition strategies to solve the crooked path problem. All right, here's what I want for you to do on your whiteboard. I want you to draw a crooked path that has 3 parts to it. I want to show you how I could do it. Oh, if I was going to do it, I could make the letter U. Watch this. 1, 2, 3. I drew a crooked path on my whiteboard. Now I want you to use your paper clips and measure your crooked path. Remember, if you drew it like I did, you're going to have 3 parts to your line. 1 part there, and then you have another part, and then you have your last part. About how many paper clips long is your letter U? See if you can solve that problem and write the number model to go with it. All right, first grade. Once you finish your practice problem, you're going to head into your seesaw activities where you're going to be measuring some crooked paths. from start to end. I can't wait to see how smart you are.